Das here from LG Institute of Engineering and Technology. In the previous session, we have discussed all about the superconductivity, right? The basic of it. Along with that, we have also discussed the properties for the same and a few other parameters also. Now, in this session, we will discuss the BCS theory of the superconductivity, and that is also known as a mechanism of the superconductivity, or it also justifies why the superconductor behaves like a superconductor. Okay, so let's begin. So basically it was discovered in 1957, that is almost after the 46 years of the superconductivity has been discovered. It was discovered by John Bardeen, Leon Cooper and Robert Schiffer. Now that is the basic reason why you are going with that BCS, right? That's why it is known as BCS theory, on the name of the famous physicist that has discovered the superconductivity. Now what is the basic theory of the BCS, or just a layman understanding definition? That is nothing but the phenomena in which the current of electron pairs flows without resistance at a low temperature. Now this is just a basic of it. Okay, so when we are discussing the just basic of it at that present time, what happens? We are just justifying it. Now in further we will discuss it. So electron interaction via phonons. Now basically what is phonon? Basically phonon is nothing but, you can also say as a bosons. Okay, but it will describe that phonons are actually the disturbance, or you can also say that the vibrations in the superconductors. Okay, now the question is, you will say that what's are vibrations? Vibration was already settled down by lowering down the temperature. Okay, now this is some sort of distorted vibration. Okay, so now we can define as when a single negative charge electron enters the lattice structure of our entire superconductor, it slightly distorts this lattice structure. This draws the positive charge around it. Okay, so this is basically definition of it. Now how it happens, you can see in the diagram, there are the lattice structure out there. Okay, so there are the positive lattice structure. Now what happens when one electron enters there and it comes at the center? What happens? As equal and opposite forces are there surrounding it. Okay, so it cannot be dragged by any one single positive charge, so it is charged that has been attracted. Instead the negative is attracting towards all the positive near it. So what is happening? It is getting attracted, and at that center surrounding, that is signified as a red portion, there a temporary positive dominated area is created, and that temporary positive dominated area is nothing but a phonon field. This was the phonon field. Now in that, if you want to study that, so you can see that what is happening. See, first we are decreasing the temperature, so we know that to attain critical temperature, after critical temperature all vibration has been settled and this electron is flowing through it, and you can see that the distortions are there. Okay, so this presently the distortion are happening, and that is the phonon has been created. Okay, now you can see in this diagram what is happening. It is actually an electron is entering and surrounding, all the positive are coming towards it, and that is nothing but the positive dominated area has been created. Now let's see what happens when next electron comes. Now when this next electron comes, both are negative charges. Okay, so when both are negative charges, it should repel, but it is not happening so. Okay, what is happening at present, you can see the diagram, this first portion is of electron is entering in the lattice structure, it is distorted throughout, and this distortion, that is a temporary positive area, or you can say that the both are having 100 to 1000 atoms of the distance. Okay, so what happens, there is a pairing of done, but actually if we see what is happening, the pairing of the electrons through the medium of the lattice distortion is known as electron distortion. Okay, or you can also say that electron interaction through phonon. So basically what is happening, it is sort of that electron pairs are there. Okay, but actually they are actually paired because of via phonon, or because of the reason of the phonon. So this phonon, that is a positive dominated area created by the first electron, is actually dragging or pairing the second electron. This is what is happening basically, but if you see from the top, you will be only able to see the two electrons of it. This is the reason how the pairing is done. Okay, now in that we will define the Cooper pair. Now what is the Cooper pair? Basically, Cooper pair is the bounded state of the electrons with the opposite spin that interact in a phonon field is called as a Cooper pair. So now we all have knowledge about it that the electrons can be of the two spins. Okay, it can be the first the clockwise or anti-clockwise, or it is also said that single spin or opposite spin. So